All right, and welcome back. So today we are going to be talking about and showing some examples of how to perform reflections on the XY coordinate plane. So without further ado, let's move on to our first example. So in this example, it says perform the reflection across the x-axis. So notice in this coordinate plane, we only have one figure. It looks to be a triangle, and it's triangle BCD. And we want to perform a reflection across the x-axis. So what I'm going to do is I'm going to highlight where I'm going to be reflecting across. So I'm going to highlight this x-axis here. So I know this triangle BCD as the pre-image is going to get reflected across that x-axis. Remember, before we do a transformation, whether it's a translation, which is our slide, a reflection, which is our flip here, or soon we're going to be going into what's called a rotation, we always talk about the pre-image. So this triangle is the pre-image because it's before we perform this transformation. Now, when we talk about reflecting, the way that I like to do it is I look at my line of reflection, which happens to be the x-axis, and I'm going to see how far away from that reflection line or line of reflection are my coordinate points. So notice how B is 1, 2 units away on top, which means I'm going to be 1, 2 units away underneath it. So that's going to be my B prime. If I go to D, that's only 1 unit away. So my D prime is going to be 1 unit away. C is 1, 2, 3, 4, 5 units away. So I have to go down 5. 1, 2, 3, 4, and 5. This is going to be my C prime. And now I can connect my shape. Notice how it looks like it perfectly has a mirror image to it, right? And they're all the same distance away from that line of reflection. I'm going to note that. Line of reflection. So it's the same distance away from that line of reflection. In this instance, it happened to be the x-axis. Sometimes we're going to be reflecting over the y-axis, right? So that's how we do it. And notice, if I highlight, notice the coordinate D and D prime. Well, what happened when we did the reflection? Did the x value change or did the y value change? Well, to see that, let's write what the coordinate point is. For D, it's -2, 1. For my D prime, it's -2, -1. So what changed here? When we flipped over the x-axis, the y value became the opposite. So I'm just going to note that up here. The y-axis, y is opposite. The x value stays the same, and that should make sense because we're reflecting over the x-axis. And the y value becomes the opposite. If it was above the x-axis, it's now going to be below the x-axis. If it was below the x-axis, it now becomes above the x-axis. So whatever axis you're flipping over, that value stays the same, and the opposite coordinate changes. So if you reflect over the y-axis, shot that. If you reflect over the y-axis, then the x value is opposite. And we are going to need this in our next example. Great job so far. Here we go. So it says, perform a reflection across the y-axis. So if I want to just show you a quick drawing of this, if I'm reflecting over the y-axis, it's this axis here, and let's just say I have a triangle that looks like this, right? When I reflect it over, notice that we're still staying in the positive y value, but my x value was positive over here. It's now negative. So the x value is going to change. So I'm going to write that. X value changes. So let's use that in order to answer this question and to perform the given reflection. So it says perform the reflection across the y-axis, and we know the x value is going to change. So right underneath it, I'm just going to write it. N prime. The x value changes. It was -3. It's now +3. And my y value stays the same. Okay? For m prime, my x value was -5. Now it's +5. And my 2 stays the same. For L prime, let me put commas here. For L prime now, it was my x value is -2, and I now take the opposite, so it's 2. And my y value stays the same. For K prime, 0 is 0, and the opposite of 0 is 0. So we still stay at 0, 0. Okay? Remember, for every time we perform a transformation, we have to add an apostrophe. Okay, so right now we did one transformation. So everything in blue, N prime, M prime, L prime, K prime, because we did one transformation. If I did another one, then it would turn out being N double prime, M double prime, L double prime, whoop, and K double prime. Every time you do a transformation, you add an apostrophe, right? So that's how we can determine how many different transformations we have done. All right, great job so far. We got one more example to go through. So in this one, it says write a rule to describe each transformation. Now we need to determine what is the pre-image and what is the image. To look for the pre-image, we look for the shape that its coordinate points are represented without an apostrophe. So I have, looks like in the first quadrant, I have I, J, H, and they don't have any apostrophes. So I know that this is going to be the pre-image. The blue figure has the apostrophe, so I know this is going to be the image, saying that this shape moved into that shape. The black shape transformed into the blue shape. So now we need to determine how did that exactly happen. With reflections, it's a little bit easier because we can say, oh, what is our line of reflection? In this instance, it seems like H and H prime are the same coordinate point. So if we just look at it, we can say, oh, the x-axis is going to be our rule here. So it's a translation, or I'm sorry, it's a reflection over x-axis. So it's a reflection over the x-axis. Another way to determine it, and it's a little bit involved, but I think you can do it, is look at a pre-image and the image of a shared coordinate point. So what I mean by that is I'm going to look at point J and J prime. What I'm going to do is I'm going to count the total distance between them and divide by 2. So I have 1, 2, 3, 4, 5, 6, 7, 8. So J to J prime is 8 units away. Well, what's half of 8? 4. So I count 4. 1, 2, 3, and 4. So I have 4 units that way, 4 units that way. which means that whatever is on that line where this midpoint is, that's going to be our line of reflection. We can also use it to show for I. Let's say we look at I and I prime. Well, let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a 10 units between them, and we know the line of reflection is right in the middle. So 10 divided by 2 is 5. So I count 5. 1, 2, 3, 4, and 5. Look at that. So I have 5 units going that way, 5 units going that way. And what do we know? We can create between 2 points a line, which is where our highlighter is on that x-axis. So that's just another way to go about it. You can also just look at it and say, oh, well, it seems going from up to down to up. That's across the x, left to right, and right to left is across the y. So there's a lot of different ways to do it. I personally like the counting method because it's straightforward, and I can always determine what it's going to be, especially when some of the shapes are a little bit like into each other, where you might have the pre-image kind of overlap into the image and the image overlap into the pre-image. It can get a little bit confusing, so the counting method is one that I always recommend because it's straightforward and you can just count it out. But that is today's set of examples. If you have any questions, please feel free to reach out. We're so proud of you. Keep working hard, and we'll talk to you soon. All right, see ya.